know why all the big important things always happen on a Sunday, but they do. Woke up this morning to no water in the house. So, let's get into this thing and figure out what the heck's going on. Let's see, we got voltage. See if y'all can see that here. Nope. You still can't. Oh, it's in the shadow. There we go. Okay, so we got power coming in. Let's see if we got 240 volts. We do indeed. So this is your limit switch here, or your overload, sorry. Let's see if our overload is tripped. So right here, we got one side of line. Here's our other side. Let's go here. Yep, we got 240. Let's go to the other side of our overload. Nada. Okay, so our overload tripped. Well, let's get us on amps here. Amps AC. Yes, very good. I don't think y'all, maybe you can or can't see that. So we're going to hit this reset and see what kind of amperage this motor's drawing. This pump's way down in the ground. Your 1.5 horsepower, 230 volt, 10 amp system down there. So let's see here. Ooh, 20 amps. Ouch. That's way above 10. Let's see if it trips that limit. I bet it does here in just a second. That's way too much. I bet the run capacitor is probably gone bad, maybe. Yeah, let's go turn the power off to it. Before it does. Oh, there it goes. Okay. Let's have a look at this capacitor. This is a 10 microfarad capacitor. 10 by 420 volt. Oof, that's a big one. Yeah, let's pop these guys off of here. Check it. This is going to be your start capacitor and your start capacitor relay. Let's switch over here to microfarads. There we go. So we need to be reading somewhere right around 10, plus or minus 5%. So, ooh, 7.3. That is no bueno. Okay. So for starters, we've got a bad run capacitor. I don't think I have a 10. Well, I certainly don't have a 420 volt one for sure. So, yeah, I guess we're gonna have to go fill up a water tank to get us some water into the system for myself and the cattle, because it's Sunday and nobody's open until we can get some parts for this guy. So yeah, right. Good morning, everyone. Just what I wanted to do today. Okay, let's put this all back together, and we'll have to get parts later. So this water tank I picked up years ago, and I use it when I'm burning brush. So what I've done is how I installed this all is similar to boats, and well, it's identical to boats really. So got a tank, got a hose that goes down in here. Here's your outlet. I just put a hose bib on the back of the flatbed here, and then underneath here we got just a 12-volt high pressure pump. Same thing you'd find on a washdown pump on boats. So that I mainly put it in when we were running, when I was burning brush, and that seemed to work pretty good, just as a backup for. But what I did is I just ran a water hose, that hose all the way over to the house down there, and hooked it up to one of the sinks inside. We got 2 sinks, so hooked it up to one of the sinks, and yeah, it worked out pretty good. That's it. That's the whole setup. Well, we didn't have much luck finding the parts that we need. This new run capacitor and start kit up in town, but they did have a whole new box with all the components. So I'm not too enthusiastic that replacing this is going to resolve our issue of our pump overamping. That capacitor is definitely bad. However, I don't think that it's weak enough to where it would only be producing, but to where it'd be producing double the amount of amperage that it should be. So we'll go ahead and swap this out just in case, but I have a sneaking suspicion that something is wrong with our electric motor down there, way down inside the well. So yeah, we'll see. Let's see here, black red. Let's open this guy up, make sure it's the same. I guess worst case scenario, if we have to have the well guy come out and pull all this up and have a look at it, and maybe even possibly replace the pump, or not the pump, but the electric motor on the pump. We'll have all new controls and nice and fresh for it anyway. So worst case scenario. Now I could just change out these components. It's the exact same model, same box, same everything, but you know, we're here, we might as well just swap the whole box out. It's about the same amount of work and time, so whatever, not that big a deal. So yellow, black, red, perfect. That's our pump motor. Red, black, good, yes, no problem, all good there. Yep, everything's the same. Let's swap it out here. So we need to disconnect our line voltage to it and our pump motor. Get you guys out of the way. I think I replaced this, I don't know, 4 or 5 years ago or something like that. It's been a while. I don't remember the last time a new pump or motor was installed. I think it's been a good long while. Ow! Jeez. Thought I turned the power off to that. Pretty sure I did. Huh. How did I mess that? Huh. Well, that's interesting. Oops. shocking experience. Don't do that at home. Always test voltage before. Which I did. Yeah, I missed a side of line when I turned the power off a minute ago. Whatever. It's probably pretty apparent that's not the first time I've ever been shocked. Maybe the first time ever on video. 20+ years of doing electrical work and heating and air conditioning, it's happened more than once. In fact, more than several times. Okay, got all that off. I have my drill over here. I got tools scattered out all over the place. They're everywhere. It's been quite a hectic past couple of weeks. I only get so much time spent at home before I gotta leave town and go work for a while, so it's quite the mess around here. There's the cows. I don't know if y'all can see that in the video. If I don't get this fixed pretty quick, they're gonna get thirsty. Luckily, we have a holding tank over here, a big stock tank, and yeah, it's completely full of water, so they're fine for a good couple, 2-3 days. Let's see, we need to get our knockouts out of here. Golly, they make these knockouts hard nowadays. Man, good gracious. I can't believe they make these so hard to get out. They used to not be like this years ago. They used to snap out pretty easy. There's one. This one is, well, it's on there for sure. Alright, come on. Wow, look at that. The whole thing's just trying to peel out of there. Phew. I'll mess that one all up. Some of these do this. They used to not be like this. Seen worse. Man, I can't believe it's so hot still. So almost the end of September. It's still 90-something degrees. Hot summer. don't know if y'all can hear the cows down there. They're going to get some water. Almost change out the box just about as fast as I could change the components out. Go. Get you guys in here without shocking ourselves. I was hoping I was going to get around to mowing the grass around here before I leave later this week, but I don't know. Be close. A lot of work left to do. Got a whole washer and dryer I need to install, including the plumbing part of it and the gas and the vent. We've never had a washer and dryer in the house, and now that I'm going to be kind of out here full time, at least when I'm home in the States anyways, it'd be nice to be able to wash some clothes. It's going to be kind of a temporary thing in our little house here till we can get a nice proper house built. First, the shop. That's going to be early part of next year. Ground put back on. I did not realize this, and actually I'm going to test this before I get it all completely hooked back up. So I was up in town talking to the well supply place, and I didn't realize that these pump motors down in the ground are pretty similar to an air conditioning compressor. They have a start, run, and common, and you can ohm these motors out, which I'm going to do here in a minute. He gave me the specs on them, so that's kind of cool. I didn't realize that. I've never worked on a water well before, so yeah, I'm going to check that out here in a minute. I have a bad suspicion that this pump motor's no good, or on its way of going out. We'll find out here in a minute. Alright, there's our line voltage hooked back up. Let's ohm this motor out and just see what's what. He gave me the specs on it, so. There we go. Well, that's the amperage on each leg. No, I needed the ohms. Well, let's see if it ohms out like a compressor does. But on an air conditioning compressor, single phase, you can go, let's see if I remember it correctly, run to common, and then common to start, and then I believe run to start should be about half the amount. Let's see. Run to common, oh God, how'd it go? Yeah, run to common is going to give you a value. And then the sum of start to run and common to start should equal common to run. Something like that. Let's see what we got here. So I don't know which wire is which, but let's go right here. Got, let's see, 2.1, 9.09, let's see, 9, and then we'll go here, 7.5. Oh, that's right. So 7.5 plus 2, wouldn't it? Yeah, there's 7.5 plus 2.5 should equal 9. Is that right? 7, 8, 9, or 9.5, which this is 9.4. So technically the windings on this electric motor down there are showing to be good. Now it could still be bad. I've seen that on compressors on air conditioners, but the windings you could have it. This actually probably will not be an electric motor issue. It will probably be a pump issue. Maybe the bearings going out of the pump, something with the pump. It could possibly be bad. And what that would be doing is creating more load on the motor, in turn making the motor overamp, hence the problem. So, but I think we'll find out here in a minute. And we might have solved our issue with a new start cap. I did not test that start capacitor, but the run capacitor was bad. The relay could have been sticking. The potential relay there could have been sticking, which would have caused a very high amperage, which it could have explained our 20 plus amps on what should only be around 11 and a half. So, all right, there we go. Yeah. So that means that, let's see something here. There's 7, 8, 2, 10. I wonder if it's like our compressors where black is typically your common, run is red is run, and then green, which is whatever. That's your start winding, which would be correct because it does go ahead and come off of your potential relay. So let's stick our amp clamp on what I believe to be our common winding of the motor. Let's fire it up and see what happens here. Oh, man. Okay, pumps on. 16 amps. That's still high. Let's see what we are total on our line voltage. 18 amps. That's less than what we had. We had 22. So we corrected ourselves with this fresh run capacitor and start, but that's still well over 11 and a half amps. Let's look at our individual windings. So on common, we're at about 18 amps. Start, 18. Oh, that's not right. This may not work like a compressor does. Oh, 1.5. Let's see something. Oh, well, according to this, that's right. Let's see. Red should be about 1.4 amps, which we're at 1.6. Black should be at 9.5, and yellow should be at 9.5. Black, 19. Oof, 19. We're almost double. I bet something's wrong with that pump. That's too much load. It's running, but we're well over what we should be at. Well, oh, there it goes. Just kicked out the overload on it. Okay, guess it's time to call the pump guy, because I don't know. If I had a way to pull this whole assembly out of here, I'm pretty sure I could troubleshoot it. I figure out whether it's the motor or the pump. But I don't have any way to pull 260 feet of pipe out of this hole with a pump on the end of it. It's going to require one of those pump trucks, or the well service trucks. So, well, yeah. All right, I'll give him a call. Maybe we'll get some video of that when he comes out here. So, all right, stay tuned, to be continued.